Hey Jade, how are you? Hi Gabriella. Is it raining where anybody is right now? I know there's kind of some bad storms in the Texas area. Is it storming for anyone? Not anymore. Oh, Christopher, I'm glad you made it. Not yet. Okay, yeah, it's like cloudy where I am, but it's not raining yet or anything. Okay, cool. All right, well, I have a couple reminders. Let me go ahead and share my slides for today. Let's see. Hi, Landon. Here are the slides for today. If y'all want to click on that link, you should be able to view them. And go ahead and do that. So here we go. Okay, so I'm going to start off with an icebreaker question today. Y'all ready? So the question is, if money were no object, what productive thing would you do? So it doesn't even necessarily have to be your like career minded, but like what would you do? And try to be specific, not like just solve world hunger, but like what would you do if you had money to do a specific thing? Maybe like a certain business that you wanted to start, or it could be a career if you want. Just interested to know, like, what would you do if you had plenty of money to do that thing? You would start a band or a space exploration program. That is so cool. Hi, Shannon. You would buy YouTube, okay? You would bribe world leaders who don't get along. Okay, that's an idea. Write a book. Start a business to help kids get started with musical instruments. Oh, cool. Like guitar, piano. Anybody have any like inventions that they have in mind where it's like something that you would want to invent? Just interested. Get a bass. That's awesome. Any other ideas? A lot of musical ideas here. If money were no object. You would build a workspace for your creativity. A microwave, but make it cold instead of hot. Okay, I love it. You put it in the microwave and it makes things cold. It's like opposite of that. Defeat atomic bombs. You'd invent a video game. That's cool. That's awesome. All right, keep the comments coming. I'll come back and look to them in a minute. The next thing I have, let's see. I don't know if you guys know this, but technically we have 5 weeks left, about 5 weeks left until your last assignment is due. So May 19th is your last day to turn in assignments. So just a reminder that summer is only 5 weeks away, and summer can be as close as 1 week away if you get all your work done, right? So you can decide when summer is if you're able to complete your work even earlier than that. But if you are seeing that you are behind pace, being behind pace is okay in this course until you get to the end, because when you get to the end, if you don't turn in those assignments, you have zeros for them. And if you fail, you fail, right? So just a reminder that if you are behind pace, you need to be coming to my classroom like daily or at least once a week. And if you don't like coming to my classroom, just know that you just got to do it. You know what I mean? It'll help you get through your assignments a lot quicker, and I'm going to be able to help you get back on track. But do not, like, just know right now that if you're not coming and you try to start coming like the last week, you probably won't be able to finish in time. So start coming now and try to get done with school early rather than being flipped and waiting till the last minute to get everything done. So if you see that you are behind pace at all, then you need to either get back on pace within like a day, or like, give yourself a goal. Like, I'm going to try to get back on pace by myself before coming to the teacher, and give yourself a goal. And if you still can't, then you need to be coming to my classroom and asking for help so that you aren't behind pace at the end of the semester whenever we close things down. So come to my classroom. The link is there. I'm sitting in my classroom all day to help students one-on-one, and I don't really have like a lot of people join all the time. And that's just my job, is to like help you guys out. And so I'm in my classroom until 4 o'clock today, until 4 o'clock tomorrow, and then we're off work on Friday for Good Friday. So come to my classroom and get those assignments done, okay? So yeah, that's everything as far as reminder goes. So our lesson today, we have a couple objectives. We're going to get through a good bit of material today. So first, we're going to figure out what electrochemical cells are, and we're going to learn how to calculate electric potential. We're going to learn how you can electroplate. I don't know if you guys have heard of that process before, but the process of electroplating. And those are the three main things that we're going to learn about today. And it sounds like, okay, that's not that bad, but it is like each one of them is like their own process. Yeah, Velvet, you're right. Forks have electroplating, or a lot of forks are electroplated. So we'll look at forks in a minute. So an electrochemical cell is something that converts chemical energy to electric current, or it uses electric energy to force a chemical reaction to happen. So they're very powerful. If you want a reaction to happen, you can use an electrochemical cell to force it to happen. There are two main types of electrochemical cells. There are Voltaic cells and electrolytic cells. So we're going to look at Voltaic cells first. So a Voltaic cell uses a natural or a spontaneous reaction to convert chemical energy into electric energy. So it's natural and it can happen spontaneously on its own. Examples of Voltaic cells would be a flashlight or batteries. Anything that's a battery is probably a Voltaic cell. Here's a couple examples of that here. And I'm going to show you guys a process of what a Voltaic cell looks like. So here, and I made this little animation in a minute to show you guys, but here you have zinc and copper with a wire connecting them. And then in the zinc, this liquid is a zinc sulfate solution, and in this liquid is a copper sulfate solution. So they're like submerged in those solutions. And look at what happens over time. So the zinc decides to give away 2 electrons so that it has a +2 charge, and it scoots into the solution, because anything that's ionized becomes a liquid if it's a metal. So it gives away 2 electrons. The electrons travel up, over, around, and then the copper absorbs them and becomes a solid. So the zinc mass gets less. Look, the zinc strip is becoming less and less zinc, and the copper strip is adding on copper to it. This is an example of a Voltaic cell. It's a really cool process there. A primary Voltaic cell, there are 2 types of Voltaic cells. Primary is one that is non-reversible, and a secondary Voltaic cell is reversible. So I don't know if we still like use rechargeable batteries, but if you have, that's a secondary Voltaic cell. It's something that can be recharged. So your phone is a secondary Voltaic cell because it can be recharged, right? There's a battery in your phone and it can be recharged. A primary one cannot be recharged. It can't be reversed, but a secondary one can be reversed. So yeah, the primary ones are less expensive, and the secondary ones are probably a little bit more expensive because they can be reversible. So rechargeable batteries, car batteries are secondary. Those are examples of secondary Voltaic cells. The next type of cell is a fuel cell. A fuel cell is a cell that produces electric current by oxidation of hydrogen. So you can kind of see this process here on this picture, but basically hydrogen goes in, and then on the other side, they react, and then water comes out of that cell. So fuel cells are, I accidentally wrote underneath it, but fuel cells are a promising source of power for the future. We're hoping that we can actually use these because they have a lot of advantages over regular batteries. Some of the advantages are that they use readily available fuels from the air. So they just take what's from the air and they use that. They also don't produce any polluting emissions. So those are awesome things, right? The disadvantages is that hydrogen is explosive, and so it's kind of dangerous to transfer it. You also need large tanks to store the amount of hydrogen that's needed for them. And there's not a big demand right now. Right now, it's not like there's a lot of people that need fuel cells. And so businesses are reluctant to invest in it because there's not really a huge demand. And so you don't want to be the first business to do it and then have to wait for everything to catch up. And so in the future, hopefully, there will be a larger demand for it. Yeah. So for fuel cells, you may need to know this for a certain assignment. So I'm putting this here. This is the oxidation half reaction and the reduction half reaction of a fuel cell. And so you can look at this. You will need to look at this when you are doing certain assignments. You can refer back to that. This is showing a hydrogen fuel cell car, and I just thought it was kind of interesting. There is so much more that I still need to learn about fuel cells and hydrogen fuel cells, but this is an idea for it's how it works for a hydrogen fuel cell car. Yeah, so I just wanted to put that in there as well. So now we're going to learn about a new topic. Are there any questions? Thank you, Azari, for sharing the slides to somebody who just joined. Are there any questions so far about what we've learned? We've learned about voltaic cells and how there's primary and secondary. And now we're going to learn about cathodes and anodes. Okay, so all electrochemical cells contain a cathode and an anode. A cathode is the electrode where reduction takes place, okay? So if something is getting reduced or its oxidation state is getting lower, that's happening in what we call a cathode. And that's also the positive terminal in a voltaic cell. So you may need to know that for some assignments. The negative terminal and it's also the negative terminal in an electrolytic cell. And so it depends on the type of cell, whether it's positive or negative. The anode is where oxidation takes place. So cathode is where something gets reduced, and the anode is where something gets oxidized. So we're going to look at an example of that here. So this process that we looked at earlier, we need to decide which one got oxidized and which one got reduced. So when you look at what's happening to the zinc, you can see that zinc got oxidized here. It went from zinc regular to zinc +2. And so zinc is going to be our anode. And then our cathode is going to be the copper because it started off as copper 2+, and then it became regular copper. So hopefully that gives you a visualization of what is oxidation. It's when the charge gets higher, and reduction is when the charge gets lower. And if something's getting oxidized, it's the anode. If something's getting reduced, it's the cathode. Okay, I just showed that again right here. Yeah, that one is where oxidation takes place and the other is where reduction takes place. The next section of this is called electrode potential. So in general, things like to flow from high potential energy to low potential energy. And you can measure how much electric potential something has, okay? So all electrochemical cells, everything has a cathode and an anode, okay? And there are ways to calculate electric potential. And I'm going to show you guys the steps for that in just a second. So basically, when we're calculating electric potential, we are referring to this standard. And basically, scientists used hydrogen as the standard reference electrode. They called hydrogens, whatever electric potential hydrogen had, they called it 0. Hydrogen was the standard. And so if another chemical has a positive value, it means that the substance is a stronger reducer than hydrogen. So if it has a positive value, it means that it's stronger at reducing than hydrogen. If it has a negative value, it means that it's weaker at reducing than hydrogen. If it's weaker at reducing, it means that it's a strong oxidizer. So basically, a positive value is a strong reducer. A negative value indicates a strong oxidizer for the most part. And so what that means is that the cathode, like we said, is where reduction takes place. And we said that the reduction is the most positive value. So the cathode is going to have the most positive reduction value, okay? The anode is going to have the most negative reduction value because it's where oxidation takes place. All of these values can be found in table B16 of your chemistry reference guide. So go ahead and click on this link to the chemistry reference guide. If you need the slides, if you join late, there's the slides. But click on that link to the chemistry reference guide and hop on over to table B16. Table B16 looks like this. It's on the physical page 64. But if you notice that when you're scrolling, like the pages are off kilter. So it's page 68 on your PDF or page 64 on the physical print. It's table B-16. So go ahead and open that up so that you have it and you know how to use it, because you're going to have to use it for quizzes and tests and on your final exam. So make sure that you can open that up. And we are going to do a practice of this now. So we're going to calculate electric potential. The first thing that you need to know is this equation right here. And it's not too bad, it's just a subtraction. So if you're trying to find the electric potential of the entire cell, you take the cathode and you subtract the anode. So it's cathode minus anode. So to find E cathode and E anode, you write the reduction reactions for both, you look them up, and then you have them. And then the substance with the lowest E is the anode, and with the highest E is the cathode. So this is actually easier when you actually do it. When we do it together, you're like, oh, that's not that hard. Let's do it together. So we're going to do one of these on a Jamboard right now. I forgot to share the Jamboard link in the slides. So let me go ahead and share it now. Hold on. Let me make sure that anyone with the link can see it. Okay, so in the chat right now, here is my Jamboard link, and we're going to start on slide number 1. Give me 1 second. Let's see. Okay, slide number 1 right here. So click on the Jamboard link. We are going to practice this. It says identify the cathode and the anode and calculate the E of the cell. So the first thing we have to do is write reduction reactions. Write the reduction reactions. So remember that reduction is when something gets lower in charge, okay? So let's do it for the copper first. First, the copper had a +2 charge, and then the copper had a regular charge of 0. Because you can see here, it started off as copper 2+, and then went down to regular copper. So all I'm doing is I'm showing the before and the after. Next, I need to decide where the electron goes. Do I need to add 2 electrons here, or do I need to add 2 electrons here? Well, it's getting reduced. It's absorbing, it's becoming lower in charge because it's absorbing electrons. So we need to put the electrons here, and that makes sense because 2 minus 2 makes 0. Electrons are negative, right? So put the electrons on the left side if it's getting reduced, and put the amount so that it cancels out to 0. So that is the reduction reaction for copper. And now we're going to write the reduction reaction for zinc. So it started off +2 and then went to regular zinc. So again, we're going to need to add 2 electrons right here because 2 minus 2 makes 0. Does that kind of make sense? Are there any questions on how I wrote the reduction part? Because that's kind of like the trickiest part is writing the reduction reaction. Everything after this is actually downhill from here. Okay, so we wrote the reduction reaction. Now we need to find the E values. Okay, find the E values in our chemistry reference guide. So we're going to switch over to our chemistry reference guide, and we're going to look for these equations. So for example, you should have table B16 pulled up, and you should see all of these reactions. So you may want to zoom in on your page. And we're going to just search for our reactions. So we're looking for Cu2+ plus 2E makes Cu. So I'm going to scroll around here, see if I can find it. Let's see. Here it is right here. Cu2+ plus 2E makes Cu, right? So I found my equation, and my value right here is 0.34. Y'all see that? So that's telling me my E value right there, positive 0.34 volts. So that's my value right here for the copper, 0.34 volts. And now I need to find it for the zinc. So I need to find a Zn2+ plus 2E makes zinc. So I'm going to let y'all call it out when you find it. Do y'all see the zinc? Zn2+ plus 2E makes Zn. What number do y'all see? Great job, Desari. Negative 0.76. Thanks, Josh. Y'all are on top of it. Negative 0.76. So that wasn't too bad, right? We just pulled up their values after we wrote them down. So step 3, it says identify the cathode and the anode. So earlier we said that the most positive value is the cathode. the highest value is the cathode, and the most negative value is the anode. So which number is the cathode? We have two numbers to decide between. We have the positive 0.34 or the negative 0.76. Which one is the highest there between these two here? 0.34, right? It's a positive number. So this is our cathode and this is our anode. So once you look up the values, you literally just decide which one is the most positive. Okay, it's the 0.34. So your answer to that is the Cu2 plus is the cathode, okay? And the Zn2 plus is the anode. So that answers the first question. And then the next part says calculate the E of the cell. So to find the E of the cell, the entire cell, you take the cathode and you subtract the anode from it, okay? So our cathode is positive 0.34 and our anode is negative 0.76. So what mistake have I made? Have I plugged this in correctly? There's a mistake that I made here. Let's see if y'all catch it. Did I make a mistake? Can you find out what I did wrong? What did I plug in incorrectly? I see Josh put a little dash there. I'm guessing that's a negative, right? Because it's cathode minus anode. So there's a minus there, right? And there's a minus here. So I need to account for both of them. So it's really cathode minus the negative 0.76 because this was negative and there's a subtraction there. So really it's 0.34 minus negative. Minus negative is a positive, yes. So 0.34 plus 0.76 is our answer. So y'all add that together for me. 0.34 plus 0.76. What are y'all getting? 1.1. Great job. 1.1 volts is our answer. So you write the reduction reaction, you look them up. Whichever one is the most positive is the cathode, and whichever one is the most negative is the anode. And then you subtract cathode minus anode. So let's try one more time real quick. Let's identify the cathode and the anode here. So first we need to write the reduction reactions for both. So y'all help me out here. Let's do the Fe first. Fe3 plus goes to regular Fe. So what should I put on the left-hand side right here in order to make this work out? Three electrons. Great job, Julia. Okay, if I put 3 electrons here, it makes the math work out because 3 minus 3 makes that regular 0 there. So plus 3 electrons. Now let's do it for the Ag, which is silver. Ag plus makes Ag. So what should I put right here for the Ag to work out? What should I put right here? On the other one, I put 3 electrons. Thank you, Julia. 1 electron, right? Okay, so now I need to go look up these reactions. So I'm going to have you all go do that. Get on your chemistry reference guide. I'm going to sit here and y'all tell me what numbers you get. So again, here is the link to your chemistry reference guide. Go to table B-16 and tell me what is the value for the Fe. So we're looking for Fe3 plus 3E. I'm seeing it on the left all the way down. If you have your table, I'm curious to see who's got their chemistry reference guide up. Go ahead and pull it up and tell me what number you get for the Fe. Great job, Dazari. So she found it right here. Fe3 plus 3E makes Fe. That value is right here, negative 0.04. Awesome. Thank you, Velvet. Okay, next one. Ag plus E negative. Thank you, Magdalene. Y'all are on top of it. Ag plus E negative makes Ag. So you're looking for that. Ag plus E negative makes Ag. Okay, I found it. Anybody found it? It's on the right-hand side, kind of mid-lower. Great job, Julia, 0.8. So I'm seeing it, great job, Velvet, right here, positive 0.80. So I'm gonna write that down. positive 0.80. So remember that our cathode is whichever one of those two is the most positive. So which one is the cathode? Is it the negative 0.04? Yeah, it's the 0.8. 0.8 is more positive, right? So to answer that question, our cathode is Fe3+. Oh, hold on, that was wrong. Our cathode is Ag+, right? And our anode is Fe3+. Okay. And now to get the final answer, we just need to do the E of the entire cell, E cell, which is cathode minus anode. Cathode minus anode. So we're going to do 0.80 minus negative 0.04. So I'm going to go ahead and guess that would be 0.84 volts. Hopefully I did not do the math wrong on that one. Okay, is this making sense to y'all? Those are the only two examples we're going to do there. They're not too bad, right? Okay, let's see. Okay, and you can see here, if you want to come back, I like worked them all out here. So now we're going to talk about the fun part, which is electrolysis and electroplating. I don't have much time, so I'm just going to real quick show you guys. Electrolysis is what you can do if you want a reaction to happen that the reaction doesn't spontaneously happen. Is you can use electricity to physically just pull them apart. So for example, sodium chloride does not want to separate, but you can separate them if you use electrolysis. And basically you have a battery, and the battery has it attracts the cations to one side and the anions to the other side, and it physically pulls them apart to make sodium and chlorine. And you can do it for water as well, like H2O. You can physically pull the H from the O, the H2 from the O, and it's called electrolysis. You need a battery to do it. There is this process for it. I'm not going to read it, but you're going to need this process in a particular assignment, and I want to help you guys out, okay, because it was really it was just kind of annoying for me to do too, and I understand that. So look at this process when you're on certain assignments, and if you need help, then just let me know. But I wanted to help y'all out there. Okay, so I was going to ask you this question before we leave. Would you rather have it pure silverware or plated silverware, or do you know the difference? If I were to offer you right now, regular pure silverware or plated silverware, which one would you choose? Okay, Brian said pure silverware. Pure. I'm seeing a couple plated. Plated. Okay, so plated does sound stronger. There are pros and cons to both. Pure silverware is literally pure silver. Pure silver can tarnish. So here are the differences here. Pure silver is basically 100% silver. Plated silver, look at this. There's a copper or a metal core, and there's a thin layer of silver around it. Most of your silverware at home probably is plated silver because it saves money and it also prevents tarnishing a little bit. So that's what electroplating is. And you can actually electroplate things at home. You can do an experiment and plate something from one metal and have it plate onto another in your own experiment at home. And I wish that I had time to do it because that would be such a cool experiment to do with you guys. But this is what electroplating looks like. You will need to refer to this process later, so I wanted you to have it here. But basically, if you have silver, the silver can basically come on to the fork and coat it with this process here, and that's what electroplating is. And I don't have much time to get into it today, so I'm going to leave it at that. And I have a learning check for you guys. And then at the end of that, well, actually, I want y'all to know one thing. When you're doing your research activity, listen up, okay? Because a lot of you guys are on this right now. Look at some topic ideas here to get started, and then email me and ask for help, because I know this is a more challenging activity. So get some ideas from that link there, and then ask me for help or join my classroom or email me, and I'm happy to help you with your research activity. But this will help you get started. And besides that, do you guys have any questions? Y'all are good to go if you don't have any questions. I'm going to leave it on the learning check because we kind of ran a little bit out of time. Y'all are definitely free to go, free to hang out, ask questions if you have any. I hope you'll have a great Wednesday.